In this chapter, we're going to take a look at bonding, both ionic bonding and covalent bonding, and we are also going to review Lewis structures. So initially, we want to consider what we mean by a bond and try to answer the question, why do atoms bond together? And when they bond together, what kind of bond do they form? The situation we find ourselves in is that there is a simple bonding method, which is essentially the one that we use, but it's not really complete. By not being complete, what we mean is it doesn't really adequately explain every possible bond that we might come up with. On the other hand, there is a complete method, but it is by no means simple. So we're going to somewhat split the difference between these two and use the simpler model with some sort of enhancements to it to try to explain all the bonds that we need to take a look at. So most simply put, a bond is just the force that holds atoms together, and it makes them function as a unit. And that unit could be an ionic compound, or it could be a molecule, and we're going to take a look at both. And to answer the question as far as why a bond forms if the aggregate, that is the ionic compound or the molecule, is lower in energy than the atoms are when they're separated. And remember that we interpret lower in energy as being more stable. The simplest type of bond that we can consider is the bond that forms between two hydrogen atoms, and we think of it in the following terms: that initially the atoms are far apart and have no interaction. They gradually come together, and as they move together, several different forces are balanced. So you have the repulsion of electrons to each other, you have the repulsion of the positive nuclei between each other, and you also have the attraction of the electrons between the nucleus of each atom. So when we do this, what we end up with is an optimum distance where all the forces are balanced as much as possible, and we have the lowest energy state, and I'll show that on the next slide. So this is a common diagram that's used to represent the bonding that goes on, or the bonding process that takes place. So let me see if I can find, yes. So we start out here, and these are the hydrogen atoms that are separated. As they gradually move closer together, then the potential energy drops, and we finally reach this minimum value, and that represents, one, the energy that's released by this system, and also, if you look at the number here, this is the bond length. If they come closer together, then the repulsion between the nuclei starts to take place and the bond becomes less stable. So there is this ideal distance. So when we talk about bond, in the case of hydrogen and with other molecules, that's what we're actually talking about. So you probably remember that we have two big categories of bonding. We have ionic bonds, where the electrons are considered to be completely transferred from one atom to another, forming cations and anions. And we have covalent bonds, where the electrons are shared equally by the nuclei. Now we can have cases that are partial ionic, partial covalent, and sort of everything in between, and we'll take a look at those. So when we have sharing of electrons, but the sharing is not equal, and that would be because one atom has more of an attraction for the electrons than another, then that is referred to as a polar covalent bond. Alright, so we have two different situations here. We have the first case where there is no charge on these two plates, and then we have the second case where this plate that I'm pointing to now has a negative charge, and over here this plate has a positive charge. And what happens in a case like that is the side of the molecule, in this case the hydrogen, is more attracted to the negative plate, and the negative side of the molecule, which is the fluoride ion, is more attracted to the positive plate. So this would be an example of a polar molecule. In other words, it's a sharing of electrons, but the electrons are not shared equally. So far we've taken a look at what we mean by a chemical bond, and we're just talking about some attraction that holds different atoms together and makes them into a unit. The explanation for why something would form a bond is to form something with a lower energy, that is, something that's more stable. And the bonding takes place by this sharing, at least for molecules, by this sharing of electrons.